The next question is the nature, size and position of image of an object produced by a lens or mirror are shown below. Identify the lens or mirror used in each case and draw the corresponding complete ray diagram in which size of the object is about half of the image. Here this is the mirror or lens. So in the first case, here is the object and this is the image. We can see that the image is real and inverted. It happens only in case of a convex lens because in a concave lens we find only virtual and erect image, and which is always diminished or smaller in size. So the first part of the question is that it is a convex lens. Now, as they said, size of the object is about half of the image. That means the image is magnified. So we can find this type of image only when the object is placed between f and 2f in front of a convex lens. So we will get a magnified image which is about double of the object. Now the second case, here this may be a concave mirror because a convex mirror always forms a real virtual and erect but smaller image, and only a concave mirror forms a virtual erect and magnified image which is formed behind the mirror. So in case B it is a concave mirror, and we can see this magnified and virtual erect image can be formed only when the object is placed between principal focus and pole of a concave mirror. So we will get a virtual erect and magnified image. Here we can see P is the pole, F is the principal focus, C is the center of curvature, AB is the object, and A dash B dash is the image of the object. The next question, what will be the colors of X, Y and Z? Here a ray of white light is falling or incident on a prism, and it has been splitted into three colors that they have shown here. So as we know by the spectrum, definition of spectrum, this ray X is the violet color ray, this Y which is in between these X and Z, it will be green, and the Z will be of red color. In these three colors, Z will have, that is the red color, will have the longest wavelength. Explain the term refractive index. Differentiate between relative and absolute refractive index. Now the value of the constant sin I upon sin r for a ray of light passing from air into a particular medium is called the refractive index. So we can write refractive index n equals to sin I upon sin r, where sin I is the sine of angle of incidence in air and sin r is the sine of angle of refraction in medium. Now what is relative refractive index? When light passes from one medium, and that one medium should not be vacuum or air, so it should be other than vacuum or air, to another medium, then the value of refractive index is called relative refractive index. And when light passes from vacuum to another medium, then the value of refractive index called the absolute refractive index.